Welcome to our first lesson in sets. So what is a set? Set is a group of well-defined objects. Set is a group of so here you will add set is a group of so we are normally what do you say? Apples, a set of apples. So we will put bracket like this. A set of, you can say apple A1, apple A2, apple A3 like that. Or we can say a set of fruits. So fruit 1, fruit 2, fruit 3. So we can, some way we can group. So we have to define the object. So we can also say a set of even numbers. So we can say a set of students in 10th A, 10th A section rather. We can make one set of numbers, set of, so we can define the object. Set is normally a group based, but one set. So what we call next is what we call union of sets. It is the set of all the elements. So it is a set of all the elements. So we can say all the elements, for example, one A set is that, one B set is that, or you can say one C, whatever it is. So all is put together, union of set. We combine everything. It's called, for example, this we mentioned, union of set. You will say A union B. That is union of sets. What is intersection of two sets? Intersect of two sets we represent like this. A intersection B. Intersection of sets. So when we say intersection of set, what it represents? It represents common elements, in both sets. So we'll take an example. So we'll take set A. So normally set is represented by capital letters. Set A like that. A to Z, capital A to Z, we represent set. Elements we represent small letters or numbers like this. These are all called elements. So, with example, we take set A. Set A, let us take, it contains alphabets A, B, C, D, E. Next, another set is that B, D, E, F, G, H. So, if we say union of the set is represented by A union B, so we write all A, B, C, D, E, D is common, F, G, H. We write. That is union of the set. Or this is the, we can call it something like master set. So, what is the intersection of the sets? A intersection B. So, what is the common elements in A and B? So, in this you see, one is D and E are common in both sets. So, intersection of sets A and B is equal to D, E. So, if you check A intersection B is same as B intersection A or A union, B union A, or A intersection B is same as B intersection A. So that is a commutation property. So this is the commutation property of the sets. Similarly, associative property also. So P union Q and then union R is equal to P union bracket Q union R, or vice P intersection, same way. So these are all governed by commutation and associative properties. So we'll mention one more property. So we have combined set A and set B and make one it's called universal set. So we represent that, for example, this universal set is A Q B. That is A union B. So this, only two sets are there in this. So what we can infer from this is A is a, we mentioned like this, subset of U. This is universal set. A is a subset. In this, yes, is contained in this. And also B is a subset of U because it's a universal set. Combining both, subset means it's a portion of it. Subset of master set rather. This U is universal set. So there's one more thing we would say. So U means you remember as universal, or it is a total combined sets rather for remembering purpose. These are all put together. So you remember in this universal set means what we are referring the problem. So sometimes it may be only AB, sometimes it may be ABC, sometimes it may be DE, sometimes DEF. So we are dividing how we want the set. Next we'll go to De Morgan's law. What De Morgan's law says. So before that we will say what is complement of set. Complement of set. So in the above example, if U is divided by A, it is represented by A dash. U means total all the elements. You are dividing that by A. A means set A here. Set A. Okay. This is universal set. So the remaining thing is A dash. Similarly, if U is divided by B, then we get B dash. So in other words, A multiplied by A dash is equal to universal set. Similarly, B multiplied by B dash is equal to universal set. So B is a subset of U. So the remaining is B dash. That way also we can remember. So what De Morgan's law says. So the first De Morgan's law is A union B. If you combine both, dash is equal to A dash and B dash. The second law is A intersection B dash is equal to A union B. A dash union B dash. This the sign changes, you see. here A dash. This is De Morgan's law. So in this, just we are trying to get familiar with the fundamentals of the set. So we'll be working out more problems the next lesson. So what is a set? Set is a group of elements, well-defined objects or elements. Union means it is a set of all elements in, for example, group A or group B. So it is represented in the bracket like that. Set A, set B. So A capital A B C D represents set name. We mentioned the name like that, something A B C D. Otherwise we have to say set 1 2 3. That is confusing. So we mentioned this capital A set. Small A B C D or elements. Small A B C D or numbers. They are of elements of the group. So union of set is represented by A U V. Intersection of the set is represented by A intersection B. So they are governed by associated combined laws. So, so we'll go to one more portion and we'll show you some examples. So we can represent the sets in a different manner also. These definitions we should go through again and get familiarized. So we can say there are two ways of mentioning a type of set. So I will come to that. It is one is called roster method or it is called list method. So what we already did is list method or the same roster method. We are telling A, the elements A, B, C, D. So we are mentioning all the list in the group. So B means, for example, another B means we can mention 2, 4, 6, 8, 10. Either dot 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 or we can close it. Or we can say this only up to this 10, 5 only. Here also we can close only 5 digits. B is a set of even numbers less than or equal to 10. That's all. We will close up to that. So there is another method. It's called set builder form or characteristic form. So we can say, for example, a set of natural numbers. We will say natural number we represent by n. We will say it is x, where x is a natural number. So we are defining we are telling it is a set of x where x is a natural. That way we write. For example, one more example I'll give you. We can also say x is a even number, even number. That's all. You can say like that. Or we can also mention like this. X, n is equal to n or n1. You can say n2 equal to x, where x is a even number less than or equal to 10. We can close. We can put some condition. So characteristic. We are telling it's a set of x. X if we are able to define it exactly, we can define the x. Or we can say it is a set of, one more example I'll give you. We can say n not number 3, we'll say b. Or you can say a. A1 is where X is list of alphabets. This is called set builder form. Called set builder form. How are characters? We are telling the characteristic of the set. N means a set of X where X is a natural number. Natural number means, so for example, this what is natural number? 1, 2, 3 and so on. So when we say N1 where X is a even number. X is a even number means 2, 4, 6 and so on. The second case also is a even number less than or equal to 10. So here it is defined 2, 4, 6, 8 and that's all. So not dot dot dot. Now it's defined. In the next case, it's a list of alphabet. So we have to write A to Z. List of alphabet is A, B, C, D. We have to write X, Y, Z. So in set builder form, sometimes we are able to define it. If we are not able to define it, we will use the roster form or list method. So with this, we come to the end of chapter 1. Please go through the definitions again. What is a set? So we should know three things. What is a set? What is a commutation property? What is the associate property? What is the complement of the set? And what is the laws associated with the sets? Thank you.